In this lesson group, we focus on what happens when a wave hits another object. It's the secret to how satellites see. We said we were really going to focus in on the cross-cutting concept of energy and matter in this unit, which means that we always need to be asking, where does the energy come from and where does it go next? When it comes to satellites, the energy that they see travels in waves, and so to track that energy, we need to recognize that when a wave hits an object, the energy either gets absorbed, reflected, or passes through the object. And so that's our mantra: absorbed, reflected, or transmitted. When light hits a tree, how much energy gets absorbed, reflected, or transmitted? A magnifying glass? Absorbed, reflected, transmitted. A cloud? Same question. With this being such an essential question when tracking wave energy, we'll spend this group of lessons making sure that our students really understand what these wave behaviors are. We get them thinking about wave behavior with this picture of a rainbow. And at the end of this lesson sequence, they'll be able to relate the rainbow to an echo and the color black and see how they're all related to the wave behaviors. We begin lesson 3.11 with a short presentation that really drives home that satellites rely on waves to capture images and data. We then rotate through 3 different stations to find out what happens when waves hit something. Now there's a fair number of materials to set up so that there are 3 duplicates of each station around your classroom. In one of the stations, students hang a metal coat hanger on their ear using different material strings, like fishing line and metal wire and regular old string, and see how sound transmits differently through those strings. They place an alarm clock in a box and stuff different materials in there to see how much each one absorbs sound, and they shine a flashlight on various different objects to explore reflection as well as transmission absorption. In the end, it's important to drive home that all waves can do all these behaviors. So light, sound, ocean waves, even radio waves do all these 3 things. Lesson 12 is part 2 of that same set of stations. Students are going to finish up with the stations, do a jigsaw of reading materials on these 3 different types of wave behaviors, where they become an expert on one topic, and then get together to share their knowledge with 2 other experts on different behaviors. They then come together to create a class-wide definition of each of these 3 processes. In lesson 13, students prove that they actually understand what happens when waves hit an object. They use different objects from our mystery box to create tabletop demonstrations of reflection, absorption, and transmission. And then the last part of the lesson, students are going to quantify these different types of wave behavior using the light sensor in the Pocket Lab devices. In lesson 14, students pull a random wave behavior out of a hat and have to come up with a kinesthetic model of that behavior with their bodies and other objects. Peers then analyze the kinesthetic model, and we really emphasize the practice of developing and using models. Students fill out a table that identifies the parts of the kinesthetic model and how those relate to the parts of the system in the real world. And now that students are wave experts, we give them a brief assessment where they can demonstrate their knowledge. In lesson 15, we introduce students to a new phenomenon, an image of chlorophyll concentration in the ocean collected by satellites. How does a satellite see the unseen? How does it measure the amount of chlorophyll? Well, students spend the day answering that question. It has to do with how the light gets absorbed and reflected. They do a reading to learn about how satellites work, and we then send students to a specific NASA website to explore different types of satellite data. What are they used for, and how do they work? In lesson 16, students begin with a recap of what satellite data looks like. But then we pose the question, how could you analyze data if you couldn't see? We listen to an extensive interview with an inspiring astronomer who happens to be blind. She converts her data to sound and listens for trends and patterns. Students then listen to sonified data themselves and draw graphs trying to interpret it. In lesson 3.17, we recap the 2 previous lessons with a warm-up, Think, Pair, Share. We walk through a presentation to help answer the question, how do satellites use waves? The presentation introduces a case study of Landsat, which is famous for its false color photographs. And we have the students look at a few specific Landsat images recorded over time. A worksheet guides them through this USGS website. We end this group of lessons with a debrief where we revisit our phenomenon, and students can now better explain what the image is and how the satellite recorded it. Now that we've seen how satellites collect their data, let's look at how they transmit the information back to Earth as we learn about analog and digital signals.